Okay, so we are moving on to Chapter 5, which is all about the integral. Chapter 5, okay. Basically, integration is also referred to as antiderivative or anti-differentiation, okay. Derivative or anti-differentiation. Okay, so basically what it means is doing everything you just learned how to do in reverse. So, like that, the last couple tests you took, you might have had a function like y equals 3x to the third plus 7x squared minus 4x plus 2. Okay, that might have been your original function, and I would have said find the derivative, and you would have said the derivative would be 9x squared plus 14x minus 4. Okay, this section is about doing all that just in complete reverse. So now you're going to start with the derivative. And you're going to have to figure out what you started with so that you got that. Okay, the symbol that we use for that is the integrand. That's that little S-like thing. So when you see that, it's telling you to figure out. It's giving you the derivative of y, basically, the derivative of the function. And it wants to know what was the original function. You have to do everything in reverse, okay? So what I want you to remember is when you learned how to do a derivative, the first thing you did is you took the exponent and you multiplied by the coefficient. And then you subtracted 1 from the exponent, okay? We're going to do those two steps in reverse order. So we're going to start with the exponent, and we're going to add 1 to the exponent. So 2 plus 1 gives me 3. Okay, and now instead of, we're going to bring down the coefficient. Okay, now instead of multiplying by the exponent, we're going to divide by the exponent. Okay, so when you learned how to do derivatives, you multiplied by the exponent, and then you subtracted 1. This time we're adding 1, and instead of multiplying, dividing. So everything's in reverse. So I simplify that, the 9 and the 3 cancel, and I'm left with 3x to the third. Okay, and as you notice, my first term is correct. So now I'm going to do that process again. This is x to the first. I'm going to add 1 to that exponent, and that gives me x squared. I'm going to bring down my coefficient, so 14. And then instead of multiplying by the exponent, I'm dividing by my new exponent. And then simplifying, and that gives me 7x squared. Okay, now here's one you have to remember. When you have a constant like -4, remember that's really x to the 0 power. So you're going to add 1 to the exponent. There's my coefficient. You always keep your coefficient, so I'm bringing down the -4. Add 1 to my exponent, that gives me x to the first. Divide by your new exponent. Well, I'm just dividing by 1. I don't need to show that. Okay, the only thing we can't do when we are doing integration is we cannot tell what the constant was. There's no way to tell. Because if you think about it, in my original problem, it didn't matter what this is. If I had plus 10 or minus 8 or minus 7.5, the derivative of all of those numbers is 0. And we have no way of telling what it was. So what we have to do is, at the end of our answer, we have to put plus C. That means there might have been some random constant, but we don't know what it is because we don't have any further information. When you're actually doing this as a word problem, then you'll have that kind of information. But right now, this is the answer to your problem. So you can see, you can check it right there with what you started with, and yes, it does match. So you've just done the antiderivative, or another fancy way to say that, fancy, is that you have just evaluated the indefinite, meaning we didn't plug any numbers in, indefinite integral. Okay, that's what you just did. All right, so let's do another problem. Let me scoot everybody up. Okay, so let's say I had, all right, let's get fancy. We're not scared. X to the fourth under there. minus 2 over the square root of x, okay, dx. So my integral symbol tells me I took the derivative of something, so does that dx. Tells me I took the derivative of something and I got this for an answer. And I want to know what I started with. So first thing first, we never deal with radicals. The first thing you're going to want to do is rewrite this. So that's x to the 4/3 power minus 2 times x to the negative 1/2 power. Remember, it's negative because it's under a fraction bar. It's 1/2 because of the square root. Okay, I'm ready to add my rules. The rules say add 1 to your exponent. Well, I'm going to put that in fractional sense in thirds, so I'm adding 3/3. So rule number 1 says add 1 to your exponent. So that gives me x to the 7/3. And then, if you will remember, then it says divide by your new exponent, which is 7/3. Okay, we're going to clean that up, but right now I'll leave that alone. All right, then I have minus 2. Bring down your little coefficient of negative 2. Okay, do your rule. Add 1 to your exponent, which in this case is 2 halves. Negative 1/2 plus 2 halves, gives me positive 1/2, and then you divide, oops, I forgot my x. Then you divide by your new exponent. Okay, I don't know if I had a constant or not. There's no way for me to know, so I have to put plus c. Okay, now I'm going to do cleanup. Dividing by a fraction means multiplying by the reciprocal. Flip that fraction upside down, and you get 3x to the 7/3 over 7. There's your 3/7. All right, when I flip 1/2 upside down, that gives me 2. So I'm just multiplying by 2, so I get 4x to the positive 1/2 power. Okay, plus my c. The last thing you need to do is, because they gave you the problem in radicals, you need to rewrite it in radicals. So I've got 3/7. Well, I'm going to leave the 3 on top and the 7 on bottom. But that's the cube root of x to the 7th. And there's my 7. Minus 4 times the square root of x. That's enough. I mean, you can simplify this and you can actually bring out x squared. But we're just going to leave that for now because we're really just working on evaluating our indefinite integrals. Okay, one more. And then I'll shut this video off and do some others. Let's see how sassy we need to be. Sassy. Sassy. 3 over x cubed plus 2x to the 3/2 power minus 1 dx. So I'm putting everything in reverse before I start. I will always rewrite. So we have 3x to the negative 3 power, right? I don't want fractions. So rewrite everything before you start. If you have radicals, rewrite. If your variable is in the denominator, rewrite it before you start. Okay, now I'm ready to go. Add 1 to my exponent. Bring down your coefficient. So I have 3x to the negative 2 power divided by your new exponent, which is negative 2. Okay, so I got that whole deal. Okay, then I'm going to bring down my coefficient. Add 1 to my exponent, so I'm adding 2 halves. That gives me x to the 5/2 power. Divide by your new exponent, which is 5/2. Okay, here's what I want to do. We already know that dividing by a fraction means multiply by the reciprocal. I'm going to go ahead and flip it upside down so it's ready to go. Okay, it's just, we don't need to keep showing division and then show flipping it. We all know we're going to flip it, so flip it and multiply. So this gives me negative 3, and then I'm going to put my 2 x's down below because that's what x to the negative 2 power means. This gives me 4/5 when I multiply, so plus 4. Now, they didn't give it to me in radicals, so I'm allowed to leave it in fractional notation. And then you have to put your random constant because you don't know if you started with the constant or not. That is my answer to evaluating that indefinite integral. Okay, Let me shut this one off. There'll probably be 2 more, and then you can start your homework.